Good morning, students. Welcome to the session 6 of the chapter of laws of motion, and the topic is the equilibrium of a particle. बोर्ड पे मैंने एक definition लिखी हुई है, that is the equilibrium of a particle refers to a situation where the net external force and the net external torque acting on it is zero. Now, or in other words, we can also say that the equilibrium of a particle refers to the translational equilibrium where the net external force on the body is on that particle or body is zero, and the rotational equilibrium where the net external torque acting on it is zero. अब इस टॉपिक को समझाने के लिए आई विल बी टेकिंग वन एग्जाम्पल वेयर I am considering a particle which is subjected to three concurrent forces, that is F1, F2 and F3. And now if this particle is in a state of equilibrium, then the vector sum of these three forces, that is F1, F2 and F3 will be zero. So this is what I have written here, that is in the state of equilibrium the vector sum of F1, F2 and F3 will be zero. Okay, if this particle is in a state of equilibrium. So now we will understand what does means how this particle will be in a state of equilibrium, means what are the conditions for this particle to be in a state of equilibrium. So ये मैंने यहाँ पे एक डायग्राम बनाया हुआ है, I will be just making it here again. ये let's say ये एक particle है and it is now being subjected to this is a force, let us say F1 हो गया, ये एक F2 है and let us say this is the force F3. ठीक है. Now this particle will be in a state of equilibrium when the vector sum of these three forces, that is F1, F2 and F3 is equal to 0. Or in other words, we can say the resultant of any two vectors. Say, let us say if I am considering these two vectors, that is the resultant of any two vectors, say F1 and F2, should be equal and opposite to the third force. ठीक है ना? That is resultant of should be equal and opposite to the third force. ठीक है. That is, if I say that the resultant of these two forces, that is F1 and F2, is, let us say it is, I'm just denoting it by, let us say R. ठीक है. Then the third force, that is F3, will be equal to minus R. ठीक है. माइनस साइन मैंने इसलिए लगाया हुआ है because this the direction of this resultant is opposite to F3. Now the line of action, ये डायरेक्शन इसका ऑपोजिट हो गया है. ठीक है. और वी कैन से the line of action of this resultant, the line of action of this resultant force and the force F3 should be the same. However, they should be acting in the opposite direction. ये line of action तो एक same ही है. ठीक है. They are acting on the same line, but F3 is acting in the opposite direction of this resultant force, that is of this resultant force R, which is the resultant of F1 and F2. And we can find the resultant of F1 and F2 by using the parallelogram law of forces. ठीक है. By using the parallelogram law of vector addition, not forces. So in this way, if the resultant of these of any two vectors is equal and opposite to the third vector, then that particle which is subjected to these forces will be in a state of equilibrium. And one more important thing, that is their line of action. The line of action of this resultant force and this third force should be the same. Line of action should be the same, means they should be acting along the same line. However, their direction will be opposite. Or direction means if F3 is acting in this direction, the resultant of these two forces, that is F1 and F2, will be acting in the opposite direction. But they will be acting along the same line, like this. F3 is acting in this. This is a particle P, let us say. So the resultant will be acting in the opposite direction of F3. Their magnitude should be equal. ठीक है, डायरेक्शन जो है वो ऑपोजिट हो जाएगा एंड देयर लाइन ऑफ एक्शन शुड बी द सेम. सो इन दिस वे व्हाट विल हैपन, द नेट फोर्स, the net external force on this particle will be 0, and at the same time the net external torque will also be 0. So in that condition, this particle will be in a state of equilibrium. Now, I will be just coming to another point. If F1, F2, F3 have components along the x, y and z axis, then f1x plus f2x plus f3x should be equal to 0. f1y plus f2y plus f3y, it should also be equal to 0, and f1z plus f2z plus f3z, this should also be equal to 0. ठीक है. Now here 1x, 2x and 3x क्या है? These are the component of forces of the force F1, F2 and F3 along the x-axis. ये F1x जो है, this is the component of the force F1 along the x-axis. F1y is the component of the force F1 along the y-axis, and F1z is the component of the force F1 along the z-axis. Similarly, this F2x is the component of the force F2 along the x-axis. This F2y is the component of the force F2 along the y-axis, and F2z is the component of the force F2 along the z-axis. ठीक है. उसी प्रकार से ये है आपका, that is this F3x is the component of the force F3 along the x-axis. This is the component of the force F3 along the y-axis, and this is the component of the force F3 along the z-axis. तो इनका जो वेक्टर सम है वो भी आपका 0 होना चाहिए. ठीक है. So अगर ये ऐसा है, then this particle will be in a state of equilibrium. So ये भी आपका एक important relation हो गया. And the most important thing regarding the equilibrium of a particle, that the particle will be in a state of equilibrium when particle is in a state of equilibrium when the net external force and net external torque. Torque is 0. अगर net external force और net external torque उस particle के ऊपर because of the number of forces acting on it. So अगर net external force और net external torque 0 हो जाता है उस particle के ऊपर due to a number of forces which are acting on it, then the particle will be in a state of equilibrium. ठीक है, so this is a brief introduction of the topic of this equilibrium of a particle, and in the next topic, or you can say in the next session, I will be coming up with a couple of questions now from the session which we have done, from the sessions which we have completed just few days back, and the session number 7 will be having a couple of questions which will be from this topic also, and it will be also from the topic from the session number 1, 2, 3 and 5. So thank you very much for joining this session, and the session number 7 will be uploaded very soon. Probably I will try to upload it today itself, and I will be coming up with a couple of good questions. So have a nice day, and till then, bye.